Okay, we're going to go through a little bit step by step the exercise 16-24 that's in your text from Hilton. In this particular exercise, we have a county board of representatives that's trying to make a decision on whether they should purchase a new sanitary landfill site or continue using their existing landfill site. Some key figures that we see in the stated problem. Number one, they'll have to pay $234,000 for the purchase price of the site itself, and then they'll have some preparatory work of $88,080 that will be in addition to the acquisition cost. Those two figures will wind up being the amount of an investment that they'll have to make at the front end of the project in order to replace the existing landfill. Now, they believe that the landfill would be usable for 10 years, and their accountant, or their hired consultant I should say, estimated that the new landfill would generate savings of $48,000 per year rather than running the current landfill, which would cost them $48,000 more. The current landfill also will last for 10 years, so you've got a 10-year outlook here and an investment that should last them 10 years. And the question is, should they acquire the new landfill or should they continue using the current one? They have set a hurdle rate. Now, what's the hurdle rate? Well, the hurdle rate is the percentage of cost of acquisition of the funds in order to make this investment. So we have to discount or to get the net present value of the savings that they would get over the next 10 years at this 6% rate. Well, let's start with the beginning in terms of the prep cost. Let me pull up the template I'm using here for capturing the solution. First of all, we're going to calculate the initial investment cost. The acquisition cost was $234,000, and we add to that the preparatory cost. And so our total initial investment, or the amount we'll have to go in the hole for, would be $322,080. Now, the next step that we want to calculate is going to be the savings on the $48,000. To do that, we need to go to the schedule that's in your text that captures the present value of the series of savings that they'll get over the next 10 years. So we look at, and that happens to be table 4 because that deals with present value for a series of payments. If we were only dealing with 1 year, that would be a different table, table 3. But table 4, we're dealing with a series of cash flows. You can see the period here. We scale down until we get to 10 years. And if you remember the 6% rate, so our factor that we need to hear, our net present value factor, is 7.360. 7.360. So let's see how that plays out when we look at the savings. So our annual operating savings would be $48,000 per year, and we have a present value factor. Using the factor at 10 years at 6%, we multiply that factor times the $48,000, and that gives us a total savings in present value terms, so that we're comparing apples to apples. What's the initial investment? That's today. What's the present value of savings over the next 10 years? What's today's value of that? Would be the present value of $353,280. So we calculate a net present value by subtracting the savings at its present value, the 10-year savings at its present value, from the initial investment of $322,000. Now, it just so happens that the savings exceed the amount of the initial investment. That's A minus B, gives us a $31,200 in today's dollars. That's the net present value dollars. So what's our decision on this? Should the board make this investment or should they not? Our decision is the board should approve a new landfill because the net present value of the savings in the operations for the next 10 years exceeds the initial investment. I hope this one helps you understand how exercise 16-24 should have of taking place.